Hi there, welcome back. I'm so happy you're here. Before I jump straight into the problem that I have put together for you today, I want to show you a free guide that I prepared for you. It is called How to Evaluate Your Engineering Education in United States of America, and it does just that. Let me show you. This is the Education Evaluation Starter Guide. It has a welcoming page here, and then it starts right away with every step you need to do to evaluate your education. Create an account on ncs.org, step number 2, number 3, gives you 4, 5, so on, and then congratulations page, and the page where I'm showing you where you can find more training and videos on my YouTube channel, FE Made Easy, is where you're watching me right now. If you are interested in downloading this file for free, please click the link below underneath this video. Okay, another important thing that I want to remind you is that if you do like this video, please subscribe and give it a like, because this helps people like you find me. It's just the way YouTube works. It helps promulgate my video in front of more people. Now let's move on with our example. A composite cable, model of elasticity 180 gigapascals, diameter of 1 centimeter, original length of 150 centimeters, is subject to the following design requirements. Maximum elongation equals to 2 millimeters, allowable stress equals to 400 megapascals. What is the most nearly the maximum permissible axial tensile load in kilonewtons on the cable? We are given two conditions. We have to meet two conditions, and we have to calculate the axial tensile load based on these two conditions, meaning we're going to have to calculate tensile load based on allowable stress and based on the maximum elongation of 2 millimeters. And then from here, we're going to take the minimum value that we get, and that value, that minimum value between these two, it's going to be the maximum permissible axial tensile load on the cable. Okay, let's start with the allowable stress. I will just quickly go to the reference handbook to mechanics of materials, and so the stress equals, just kind of want to show you where you can get these formulas in case you just don't know, you're not familiar. So this is the stress formula, and this is the elastic longitudinal deformation. And these are the formulas we are going to use. So first, let's start with the allowable stress. So we know that the stress equals to the load over the area. And from here, the load equals to the stress times the area, which equals to 400 times megapascal is going to be 10 to 6 pascals times the area, and we have to work in meters. So diameter is 1 centimeter, that means is 0.01 meters, and the area is pi times diameter 0.01 squared over 4. And we get 31.416 newtons, and this will equal to 31.4 kilonewtons. And this is our load, maximum load due to our allowable stress. And now let's calculate the maximum load due to the maximum elongation. And going back here, the formula, the elongation equals to the PL over AE. So let's just write this formula down. PL over AE. And from here, we're just going to calculate the P, the load, which is going to be equals to deformation times A, elongation part times area times the model of elasticity over the entire length. And here we have 2 millimeters, which in meters is going to be 0.001 multiplied by the area, which is pi times over 4, 0.01 squared times model of elasticity is 180 times 10 to 9 gigapascals and divided by 1.5 meters, 150 centimeters to transform to meters, just divide by 100. And all of this is going to be equal, here deformation 002, it's 2 millimeters. So 2 millimeters divided by 1,000 to transform to meters, we get 0.002. And from here, we get that the load equals to 18,850 newtons, or transforming to kilonewtons, 18.85 kilonewtons. Okay, so now we have our load calculated from both of these formula, and the maximum permissible axial tensile load is going to be, let's call this P1 and this P2. So this is 2. It's going to be minimum between P1 and P2 and equals to 1885 kilonewtons. And looking at the results, the correct answer is D.